So this is the day 2 of Law of Science on what we call the ambiguous case. We investigated this in class, so I just want to solidify a few things. Just a reminder, Law of Sines looks like, sine A over A, sine B over B, sine C over C. Or you can use reciprocals. Again, there's 3 situations. We use the law of sines: angle, angle, side, angle. We've already practiced those 2. We're moving on to the ambiguous case, which is the SSA triangle. The problem with the SSA triangle is that when you're given 2 sides and the non-included angle, let me sketch what that looks like real quick. So here's the 2 sides, and we're told what this angle has to be. The problem is the side that I drew as a dotted line down here, it's not set in stone how long that needs to be. So that means we have kind of this hinge situation where the side that's right now, right here, can swing and create a second triangle where we get, instead of an acute angle here, we get an obtuse angle here. This means that in some cases we'll get 2 possible answers. Some cases there'll still only be 1, and then there might not even be any solutions in some cases. First, let's start off with one solution. This happens when you get this side, for our purposes right now, we'll call this side A, across from angle A. If that's longer than the other side, if it's an acute or obtuse triangle, so here's an obtuse triangle where side B leans the other way. So as long as A is greater than B, and you can do a quick check on that because you'll be given those 2 sides, you only get 1 triangle. Or if A isn't greater than B, but A happens to be the height, which makes it a right triangle, you'll only get 1 triangle. So you don't actually have to test for this case here. You don't have to do anything ahead of time. It'll kind of come out through the solving process. You'll get no solution if you get this side, which was A, and this was angle A. If it's too short, technically speaking, if it's shorter than the height from this point down to this dotted line side. And we get 2 solutions, like I mentioned and like you saw in class, when this side is longer than the height and not longer than the other side given. We can kind of swing it like a hinge, and we get, let me see if I can use colors to point this out here. We get this bigger triangle here, but we could also get this smaller triangle here. This one's not a triangle because it doesn't use this side, it goes too far down. Another way of describing those would be to say, the acute angle here or the obtuse angle here. So this one is acute and this one's obtuse. If there are 2 solutions, there's a relationship between the acute and the obtuse angle. They'll be supplementary. We call them both, if this is angle A or alpha, then these 2 are beta or B. Angle B that comes from the bigger triangle will be the acute angle, and this angle over here will be supplementary to this one. This is because these 2 sides have to be the same. Like if you overlap the 2 solutions, those 2 sides are the same because what we were given. We get this isosceles triangle here. So this angle is congruent to this angle, but these 2 angles add up to 180 degrees. So this angle must be the same as 180 minus this angle over here. That's kind of the complicated way. We could also remember that if the sine of 2 angles is the same, like so this, remembering that inverse sine had 2 solutions, one angle and then the supplement of that angle. Here's my method for determining the number of solutions. We go through the whole process of using law of sines to find the second angle. Then a second angle, so it's the first thing we solve for. Then we subtract that from 180 and we see, could we build a second triangle with that angle? So we're going to check with the first angle that we were given and see if there's enough left over to make a second triangle. Let me run through, I'm not going to completely run through the examples, but I'll show them to you and you can stop and pause and jot this stuff down. So we're starting off, and I didn't like this diagram because it's sideways from the way I usually draw it. But here's the angle we start with. Sorry. And we're given that there's a side 10. Now the 10 could either be here or it could be up here. Using the law of sines, they do sine of 56 and 10, these two across from each other, equals 12 over the sine of, they call it q. Whatever, it doesn't matter what you call it. So they solve for it, and actually we end up solving for this one first. You're always going to get the acute answer first. And by taking the inverse sine of what they get an angle of 84.2 degrees first. Now, to get the 95.8, that's the supplement. So that's 180 minus 84.2. And we check the 95.8 with this original angle up here, which is what I've shown here. Since that's enough left over to get a third angle in the triangle, we have two possible angles. So basically, if this angle Q2 really is 95.8, then this angle up here would be, 29 or about 29 degrees or 28 degrees. Let me show you this case here. When they solved this one, sine of 116 over 8.3 equals sine of q over 54, we found that we had the first solution that we got was 35.8. 180 minus 35.8 left us with 144.2. When we take that with the original angle, we get a number greater than 180, which means we don't have enough degrees left over to give us an angle R, so there's only one possible triangle. That's it for this. I know that was a little bit lengthy, but it's a tricky subject, so we're going to spend some time in class practicing it.